Forming brake lines is not only cost-effective, there are instances where a brake line cannot be found. This is one such case. It's a classic Chrysler car with dual-plane brakes, 2 semi-wheel cylinders, and a connecting pipe. This pipe had to be formed to replace the original corroded and deteriorated piping. Using the right tools is always important, and in this case, flare nut wrenches, special wrenches like the X-Force flare nut wrench, are essential parts of brake service. There are also specialty tools for flaring brake pipe. While this tube may appear to be simple, it's not. There are compound curves, sharp angles, and the need for a uniform 45-degree inverted flare seat with a 45-degree inverted flare nut at each end. These threads are 3/8 24, and the flare nut wrench is 3/8 inch. Always use extreme care when starting threads on a wheel cylinder, master cylinder, or caliper. To prevent damage to flare nuts, use the proper tools. This Bonnet wrench has been in my toolbox for decades, but the modern equivalent that takes it to the next level is the X-Force from AGS Company. Here we're limited by space, and although the AGS tool will fit on this nut, it will not fit on the other one. So we turn to the traditional 3/8 inch brake flare tool. Since these seats are brass, we'll snug the nut up, then back it off. And snug it up again. The idea is to center up the tube and form the tube to the brass seat. Since we're forming the tube and seat, it's necessary to secure the flare nuts snugly. And for this size flare nut, a torque of 14 to 15 foot-pounds would be plenty. Avoid rounding the corners on flare nuts. We'll let this set for a few minutes and then come back and retorque the nuts. Once formed and secured properly with the flare nuts tightened to the proper torque, note that there is clearance between the moving parts on this center plane brake system and the tube to avoid chafing. The tube in this bent position is somewhat rigid and resistant to vibration and damage. This is following the factory method of forming the tube and the factory method of mounting the tube to clear bolt heads and other moving parts. Note that there is clearance between the brake pipe and the center plane plate as well as the bolts. When the center plane brakes rotate, the tube will be unaffected and undamaged. Recheck the flare nuts for proper torque. Do not over tighten, but make certain that the tubing flare is seated in the wheel cylinder seats. The passenger side and the driver's side of the vehicle have different contours to this brake pipe. This is the passenger side tube. As shown here, our template for the driver's side will be completely different. The driver's side contours fit in the opposite direction at the left side of the vehicle. This will be our template for the driver's side tube. While we could pattern and form this tube on the bench using an SUR&R turret flaring tool, we've got a better approach and can actually form this tube at the vehicle and be more precise at the same time. Let's start by measuring the tube and its radiuses with a soft tape. Allow for the flare and take into account the radius of each curve. In this case, we have the advantage of the original equipment tube to use as a template in constructing a new replacement tube. We're at 15 inches, so let's make this 15.5 inches to allow for the flares at each end. Again, if we were forming this tubing on the bench, we could use a tool like this turret type high-speed Super Duty flaring tool, the FT351 from SUR&R. A tool of this type would do an excellent job on the bench. To save time with on-the-chassis work, we've turned to the SUR&R PFT409 hydraulic flaring tool that can be used under the car, or in our case, right at each wheel. The PFT409 pistol grip flaring tool consists of the hydraulic flare tool itself, the D39 hydraulic flaring tool, a set of dies for 3/16, quarter inch, 5/16, and 3/8 inch tubing, and adapters or punches that include the 45-degree inverted flare cones and adapters for DIN 3/16 and M475, DIN quarter inch, DIN 5/16 inch or M8, DIN 1/4 inch or M6, DIN 3/16 or M4.75, M5, 3/16 inch and metric 4.75 millimeter, quarter inch or metric 6 millimeter, 5/16 inch or metric 8 millimeter, and 3/8 inch or metric 10 millimeter. These punch sets and dies enable forming 45-degree and DIN flares under the chassis or in a location like where we're working now. In my shop, I do a lot of work at this level, and the Mechanic Sidekick toolbox is a tremendous asset. The box has 2 drawers for tools. It makes it very convenient to put parts or tools right where they're within reach when you're working on a project. There's additional storage on each end of the box, and these trays fold up and out of the way for tighter working space. This is a rugged and durable piece of equipment. It feels solid underneath you when you're sitting on the stool. And this is a nice cushion area. Here the convenience of the Mechanic Sidekick toolbox is obvious. Tools are readily available when needed. The rolling casters make it very easy to position yourself when working on a project. Creating flared tubing always begins with proper preparation of the tubing. Here, we'll use some tools from SUR&R and start the process with a tubing straightener. This SUR&R tool is ideal for that. And although there are tools that have rollers and are much more expensive than this, with proper use of the tool, you can get the job done. We're straightening out a stretch of about 18 inches of tubing. Our finished piece will be 15.5 to 16 inches. Tubing straightening and tube flaring is an important part of brake tube plumbing. The first step is to cut the tubing. Let's begin with 16 inches, approximately right here, which will require straightening this last section of tubing. We'll mark the tube at 16 inches. We'll make that 16 1/4, so we can always suck up an extra 1/4 of an inch and cut the tubing in that position. For tube cutting on stainless steel, I use this rigid number 15 roller type tubing cutter. But for this mild steel tubing, I'm using the SUR&R ratcheting tubing cutter. Which opens up on one end. Some prefer a mini tubing cutter for this type of job, and in tight quarters a mini tubing cutter often works well. Small bites are less apt to work harden the material. Using a quality tubing cutter will give you a square end on the tube, which is essential for the flaring operation. We still have a slight curve on the end of this tube, which we can easily straighten with the SUR&R tube straightener. This tube straightening pliers is quick and also serves a double purpose of enabling us to hold tubing while we're either cutting it or handling it. When we start tubing, this is the end to start the tubing from. If this were a straight stretch of tubing on the frame or axle, this tube bending pliers is fully capable of getting good results. The next step is to deburr the ends. In order to do that, we have a choice of two tools. This is one I prefer for inside and outside deburring, and it gets excellent results. This is the RM69 inside reaming tool from SUR&R. Note that I'm deburring this tubing over the top of a trash can. I don't want any of the burring material to get near the open braking system. This is 28 thousandths wall thickness steel brake tubing, original equipment brake tubing that is easy to flare and also easy to deburr and cut. For uniform flares, do not overlook this process. Deburring is crucial to getting an open orifice and no debris when forming the flare. The RM69 brake tubing reamer is made in the US and is a quality tool. Let's finish the deburring process with an outside reamer. This is a 45-degree chamfer that I'm forming on the outside of the tube. Serves the double purpose of deburring and also creating a chamfer or smooth surface with a slight rake. This is 3/16 inch brake tubing, 28 thousandths wall thickness. I like to blow compressed air through the tubing before forming the flare ends. The rigid number 15 roller stainless steel tubing cutter is ideal for a variety of uses, including copper, mild steel, and stainless steel brake tubing. Copper would be NiCop, not pure copper, but nickel copper, ultra bend, and NiCop. The rigid tubing cutter tends to compress the end, and it's obvious here why we need to deburr or ream the end of the tubing after cutting it squarely with a tubing cutter. This again is the SUR&R RM69 reamer. Made in the US, does a nice job on inside reaming, though it does not have a provision for outside chamfering. That cleaned right up. This will help the tubing fold during the flaring process and also produce a burr-free and smooth inside diameter on the inverted double flare that we're creating. Now the wall thickness is uniform and there's a nice chamfer on the end. The tubing is reamed and ready for flaring. I like to clean the tubing with compressed air. This classic Chrysler car has a single braking system like many Jeep vehicles and early vintage trucks. And the last thing you need is metal debris in the hydraulic braking system of a single master cylinder. Before bending the tubing, make a point of putting the flare nuts in place. These are 3/8 24 thread. Always use quality parts and be certain that these flare nuts are aligned before bending the tubing. We'll begin by creating a tubing flare on one end. One of the features that I really like about the PFT 409 is that the smaller dies, like this 3/16 inch 4.75 millimeter, have smooth channels. These smooth channels prevent chafing or marring of the tubing below the flare. The indexing pins keep the dies aligned as you assemble the tool. In this case, we'll form the tubing with the flares as a straight piece and then make our bends. Let's begin by inserting the die halves and the tubing into the yoke. Make sure the dowel pins are aligned and close the gap with the screw without tightening the screw at this point. This is the hydraulic flaring pistol. And it simply drops into this end of the yoke. This is a very quick tool to assemble and is ideal for working underneath a vehicle. The first step is to square up the tubing with the end of the die. And this is done with the first operation punch. We want the tube to be flush with the end of the die. Snap the punch into place. Again, the screw should be barely finger tight. Squeeze the pistol grip handle and notice how the pistol can be rotated for convenience. And once that's flush, we'll tighten the screw using the handle. Tighten the handle securely. We'll change punches to the first step punch for an inverted double 45-degree flare. This is the operation 1 punch. Drop it into the tool. It's held in place, which is very convenient. Make sure that the tool is retracted completely so that the pin will drop into the center of the tube. There are adjusting set screws on each side of the head, and they can be used to center the punch with the tube. Make sure that the punch is centered to help preserve the punches and ease tube forming. I like to use red rubber grease, as I've described in other videos on tube flaring. This fresh grease gun is dedicated to the Miller red rubber grease, and I use it for brake tubing and brake cylinder work. Red rubber grease is a castor-based grease that will not harm natural rubbers and other rubber compounds. To ease the flaring and protect this tool, I'm using red rubber lube. This red rubber grease, if any residue whatsoever remains in the hydraulic tube flare, will not harm the braking system. Never use petroleum-based grease around hydraulic brake parts and rubber seals. The tube is square with the die, and we insert the hydraulic flare tool. The pistol grip hydraulic flare tool is retracted completely. Make certain that the center dimple on the punch is centered on the tubing. This is the first step of an inverted 45-degree double flare. And we begin by making sure that the punch centers with the die and that there's no restriction or interference. The tool has considerable hydraulic force. Squeeze the handle until resistance is met. I use short uniform strokes and stop when firm resistance is met. Retract the punch. And the first step of a 45-degree inverted flare has been formed. We'll change punches to the 45-degree cone. This will form the double inverted flare. Make certain that the tool is in retracted mode. Drop it into the yoke. Again, make sure the cone is centered with the tubing center. Contact is made. Continue moving the handle, making sure the punch is centered on the die. And pump until resistance is met. Firm resistance is sufficient. Don't overdo it. We're forming tubing, not crushing it. Retract the punch. Remove the punch and hydraulic cylinder. And there's our 45-degree inverted flare. Note that the 45-degree inverted flare is formed. We have a really nice shoulder on the flare. The 45-degree seat will fit nicely against that shoulder, and this flare is now ready for service. We'll blow compressed air through here, and that will remove most of the grease. An optimal flare has been formed. The inside diameter of the double inverted flare is exactly the same diameter as the tube. We'll perform the same steps at the opposite end. Note that this end of the die is for DIN, and this end of the die is for a 45-degree inverted flare. Roughly square the tube with the end of the die, leap it out just slightly. Secure the screw finger tight. Start with the first operation, which has a flat end. Insert it into the holder. The punches will not fall out during a flaring process under the car and roll across your shop floor. Bring the tube flush with the die end. Clamp the die firmly in place. The die halves will secure the tube without marring. Again, note that both of our flare nuts are in place. The tube is square with the end of the die. We move to the first step flaring operation by changing out the operation 0 with a 3/16 inverted double flare punch. Snaps clearly into place. Release the tool completely. Make certain that the punch is retracted completely before dropping the pistol grip hydraulic tool into position. And be certain that the dimple on the punch is centered with the tube. As the punch enters the die, be certain that there's no friction and that the punch is centered with the die end. Squeeze in uniform strokes till resistance is met. Release the punch. Make certain it's retracted completely. Change to the cone punch. This is our 45-degree cone. Snap it into place. Make certain that it's on center. Insert the pistol grip hydraulic flaring tool into position. There's a nice first stage step of the flare formed. Again, make sure that the punch is centered with the tube and also centered with the die set. And perform the second stage inverted 45-degree double flare. When clear resistance is met, that's enough force. Stop there. Release the punch. And there's a beautiful 45-degree double inverted 3/16 inch flare seat. The measure of a quality flaring tool is its ability to make repeatable, consistent flare seats that you can trust are on a 45-degree angle. Back the screw off. Remove the die halves with the tube. Separate the die. And note the quality of this flare. There's your 45-degree double inverted flare seat. The inside diameter of the inverted flare is the same as the diameter of the inside of the tube. There'll be no flow restriction. The shoulders of the seat are uniform. There's no chafing or marring or nicking or impressions where the die set clamps. This is a nice, neat way to flare. Fast, consistent, and cost-effective. Note that the 45-degree bevel on the flare nut comes up and seats nicely against the shoulder of the double flare, and torqued into position properly. This will provide the kind of seal we need for 1400 or higher PSI sealing. Bending tubing with these kinds of curvatures requires a good tubing bender. There are several types of tubing benders. I'll go over the tubing benders that have worked for me. From the oldest tubing bender, this Imperial Eastman, that ironically is one of the best tools in the field in that it can bend a tight radius, in this case on 3/16 or quarter-inch tubing. The other tube bender that served me well is this KD 2189 that I bought years ago that works with quarter-inch as well as 3/16 inch tubing. It bends a concise, uniform radius on the tube and works very well. For more contemporary tools and a highly accurate bend, this is the Master Cool 4-in-1 tool that can bend a precise radius of 45, 90, 135, or 180 degrees quite readily with 3/16, quarter-inch, 5/16, or 3/8 inch tubing. The tubing bender that we'll try today has a nice radius to it, and this is the SUR&R tubing bender for 3/16, quarter-inch, 5/16, and 3/8 inch tubing. This is a very easy tubing bender to handle. Let's see what kind of radius we can make with this tool. Recall, the overall length of this tube should be approximately 15.5 inches. And we're there. That's flare end to flare end at 15.5 inches. What we'll do now is take a practice piece of tubing and experiment a bit with the SUR&R tube bending tool. A concern we have with this particular project is how tight the bend is, and it's actually a compound bend. and whether we can accomplish that with a tubing bender. The similar bend on this radius was actually formed with the Imperial Eastman tool. And I very carefully formed that radius. It's a double compound curvature, and that was accomplished with this older design tool. In this case, we're replicating this shape to the tubing. We'll cut some tube and see what we can do with the SUR&R flaring tool and compare that to the Master Cool tool. So let's compare bends with different types of tubing benders. Again, this is the SUR&R tubing cutter. This time let's use the tubing cutter in ratcheting mode. The technique is to close the gap on the cutter, and once closed, turn the cutter knob 360 degrees. This sets the mode for ratcheting. We're trying to match this compound radius, the tight curvature, and the bend at the end. This bend at the end can be done with an entirely different tool that I'll demonstrate in a few minutes. So our main goal at this point is to create a radius in this degrees. Let's try the SUR&R tool. This is a 3/16 inch groove. And this is the extent of the radius. We can make a nice 90-degree bend, but we can't take it further than that. So let's try the Master Cool tool. We'll use the groove for 3/16 of an inch and see if we can take this existing radius around a bit and see if the curvature is the radius that we're looking for. We'll do that with a fresh section of tubing. And we know we're looking for a 180-degree bend. We're coming around that far, and see if we can get a radius that's that tight. Here, it's obvious that we've made a beautiful radius, but there's a problem. For this particular project, the radius needs to be much tighter than that. So the Master Cool tool, which would be ideal if we could make the radius this large, is not suitable for this particular bend. And I think we'll have a similar issue with the KD tool. Let's see how tight this radius can be. Here, the plier end of it is already closed, and this is the extent of our radius. We can come around further and see if we can decrease the radius, but really we're limited here. Despite the fact that the other tools are optimal for certain radius bends, in this particular case, the old Imperial Eastman tool will be our tool of choice. Watch how tightly we can bend this radius with the older Imperial Eastman tool. This is much closer to the radius that we're striving for. So in this case, we will carefully make this bend on the new tube with the Imperial Eastman tool. An added step that you may want to take with flare seats is the use of Scotch-Brite very fine pad to smooth out the seat and make certain that you have a good contact surface with the wheel cylinder, caliper, or master cylinder flare seat. You're not removing metal, you're merely polishing the flare. After this step, I'll blow the line out again with compressed air. The idea is to make sure that there's no debris in the lines and that you get a solid flare seat seal. Brake pressures can run up to 2,000 psi, and you certainly want to make sure that you're getting a good seal. Also, there's electroplating on the tubing, and you may want to just polish the backside as well. This won't remove the electroplating. I'm merely polishing up the zinc coating. The beauty of the PFT 409 tool is that it has left no marks or marring on this section of the steel tubing. It's just an extra step. The flare seats on the cylinders are brass, so there is good conformity. This is just added insurance that there's no debris inside the lines and that the tubing seats properly. Note that the inside diameter of the inverted 45-degree double flare is identical to the inside diameter of the tubing itself. This assures that there will be no restriction in the fluid volume flow. We can bend the tube to match now, and that's our next step. Again, our tool of choice for forming this radius will be a tool probably as old as this Chrysler itself. This is a 60-year-old tube that was formed at Chrysler to fit on this center plane brake set, and we're going to replicate this corroded and worn tube. The first radius is right at the end, so there's really no room for stick out at the flare nut. In this case, running the tube this far out, which would be the norm for this radius bend and the use of this tool, would give us too much stick out length, and we don't want that. The radius we're trying to form on the tube is very close to the SUR&R radius for the 3/16" tubing. We need to form the radius from the flare nut outward. So in order to do that, I'm protecting the threads on the flare nut, which is held by masking tape to the end of the line. And we'll very carefully try to form this on a radius that will put the back side of the flare nut right here and this side of the radius to this point. Let's see how that works. Now we can coax that along by holding this in place at this point and bending the tubing to match up with the radius like that. And that's virtually as far as we're going to go with the tool. So what we have is a smooth radius here. And this is what we're looking for when we bend tubing. We don't want any kinks or to overstress the inside of the tubing. So this is a good radius. And we can tighten that up a little bit. So we can look at it this way. And the idea is to bring the tube around in this area to match up with the radius on the end of the old template tube. So let's see what we can do with that. I have this tool that is very popular in the tube bending aftermarket. As it comes out of the package, the channels are extremely rough and chew up the tubing in the process of bending the tube. So I've taken a deburring tool and smoothed out the channels on both sides so that the tubing can be bent without it kinking or marring the tubing. And I'll show you how that works. We'll hold the tubing here and very carefully bend the radius. I'm applying pressure to the backside of the flare nut to avoid kinking. Recall that what we're trying to do is continue the radius, so I'm applying pressure on this side as well. And we don't want to kink the tube here. Again, let's compare it with the radius, the original tube, our template, and we're really close to where we need to be. The radius is right. We need to bend the tube downward, and it will also go over this way. So in order to do that, we're probably better off threading it into the wheel cylinder and doing the finish forming at that point. The option is to form the radius around a cylindrical object. In this case, we can use a socket, deep set socket, that has the same radius. This will keep the tube from kinking on the end here. Let's take it around. And our final bend will be this way. And to do this, I don't want to apply pressure. I'm backed up to the nut to avoid kinking or marring the tubing. I want to get this compound angle right, so I want to use the template as a guide. And bend it right here. I want to roll the tube. Take it further. and that should be a good matchup. We're a little bit longer here, which is not a problem. The radius will stand out further, but we have plenty of room for that, and that should do it. Tubing threads have been protected. You can remove the masking tape at this point. Actually, before we do that, let's polish up the tubes using Scotch-Brite. This is very fine. The purple. There's no nicking or marring in the tube. That's critical. Again, the modifications to the bending tool that I just demonstrated were essential. Had I not done that, it would have chewed the tube up. And in this case, there are no marks whatsoever from the bender. And the masking tape was effective. There is no damage whatsoever to the threads. Took some time and patience, but there's our radius. At this point, we have a sweeping radius further down. We can form this now. And then all of this can be adjusted in position. But we can accomplish this much now. We're going to bend this by hand. Even though this is steel tubing, it bends in 3/16 diameter. Tubing bends well. And remember, we have compound angles here, so we're going to keep the tubes parallel. Anytime you're bending tubing, the tubing bend should be mild, very carefully plotted. I'm holding the two tubes closely together and forming the new tube around the radius of the original tube. Again, some final bending can take place in position. We're just trying to get it roughed out at this point. Now, at this stage, with the two tubes parallel, we have a slight bend over this way as well as continuing the radius. So we'll hold the tubing tightly together and bend both directions. We have a bend at the end, a radius, and we'll form that in position because I'm concerned about length and where everything lines up. So basically this is going to do it for the moment. We may need to go outside a bit to heat up some of this space here. And in the event that we need to do that, I don't want to have a tight radius on this until we're ready to actually install it into the wheel cylinder. Here we've started the threads of the 3/8 24 flare nut. Run them in only finger tight. Be careful with the flare nuts. Make certain that you do not cross thread them. This is a classic wheel cylinder that we can hardly afford to damage, so extreme care was taken running the flare nut in. Shape the tube. We want to use the original tube as a template in this case. You can see that we're close in shape. And at this point, I've taped the flare nut as we did on the other end, and we'll use the SUR&R tool with plenty of masking tape protecting the threads of the flare nut to do a compound bend. What we're going to do is, instead of bending just 90 degrees, we're going to bend an angle at this point right here, but simultaneously take the flare nut to the entry point, approximately this angle, on the wheel cylinder. So this is actually a compound bend. You have the flare nut all the way out. Okay, a little bit tighter and we'll have it. At this point, with the bend started, I think I'm going to stop using the SUR&R tool and get the Imperial Eastman tubing bender. One of the things I like about the Imperial Eastman tool is that it's very smooth channeled and does not mar or in any way cause blemishes. So here we're going to continue our radius. These tools were very popular in the day, and you can see why. I take the flare nut out to the end, still protected by masking tape. Put the clasp over the end, and we can very carefully move this tube right into position. And we can form our final shape once the tubing is started. Again, we've protected the flare nut. And you can see how close we've come with the position of the nut to the wheel cylinder threads. And we'll work on that. Always start the flare nut by hand. Notice that the tube is centered up. And once the threads have been started carefully, you can use a flare nut wrench to continue tightening. Make sure that the other end is also started properly. Do not tighten fully yet, because in this case we're going to form the tube more closely to its final shape before we tighten the flare nuts. We're tightening the other end very lightly at this point, just to align the tube. That's it. Now, with both ends just barely snug, we can shape the tube to its final form in position. Again, the benchmark is the original tube. We want to stay within the margins of the brake shoes and other parts, and we don't want the tube to rest on any moving parts or in any way be in a position to vibrate or chafe. So I want to bring it out here slightly. We did this on the other side. Once the nuts are tight and the tubing is snug in the flare seats, with these bends it will stay in position and not vibrate. I'd like a little more clearance here. And this can come in slightly. We want to keep the tubes on center with the flare nuts. That's centered, and so is this. To assure that there's adequate clearance, we'll compare that with the 12-inch brake shoes that were standard. Make sure that the stick out of the tubing does not interfere with the brake drum or the shoes. We'll want to bring that top bend inward some, and otherwise the tubing looks like it's aligned properly. So here we'll use the tool to hold the tubing right at the top end of the flare nut, and we'll bend the tube this way. We'll try another technique. Here's a deep set socket that can provide a radius for this purpose. By the time we bend this over this way, we'll have what we want. And there's the match we're looking for. On this section, we'll provide a radius to match the original and form that by hand. It's a slight bend this way, as well as this way. When we install the tube, we can make the last tweaks that we need.